Sample.
Apparently I've got Connor McDonald Oracle now.
There you go.
Yeah.
Now, before anyone thinks this is like me just being incredibly vain, like with a camera, we're actually live streaming this to the East Coast as well. We're doing experiments. So yeah, so we're talking locally, but also there are people joining us from over East. That's why you can see the bits. Let me change this. That's right, yeah. It's like, we could have some fun with the people over East, but just like looming in like that, but we won't. Let me just change the slides over.
No speaker behind you.
So, let's see if we can. Okay. Let's start the other slideshow. Okay. Thanks, Dana. Oh, no, I'll keep that. Thanks.
Would anyone like a glass of water?
Cool, let's see this. Cool. Everything seems to be working. Little sip of coffee and we'll get going. Oh, yes, I need to take a picture for posterity. No, at least this way. That's right. These are all the people that are prepared to present at the next event. Fantastic. Welcome all. For most of the thing, I'll probably stand in between the two screens, just obviously so I don't block anyone's view, and also in lieu of the fact that I didn't bring a wide enough angle lens, so that's the best my camera can do. But it's 8:29. How long have we got? Like, Chris, we got 60 minutes, 90 minutes? Anyone know? 90 minutes? Good. So the plan here is today is to talk about 60 minutes of features of technology that exists today. And then, unfortunately, we will say goodbye to our online audience, and then we'll do some talking about 30 minutes of features which are planned but not confirmed for in the future. So this is cool because I thought you guys, you've made the effort to come along. You'll be one of the very few people in the world that get to hear this kind of stuff. So it's brand new stuff, all very much up in the air. So that's why I said it's 21C, why not, and beyond. And we'll see how we go. Now, in the good old days, you'd say, you want to get in touch, here's my email address. But nowadays, like, you can get in touch with Twitter, LinkedIn, Facebook, Instagram, you name it. So rather than that, I just get a simple QR code. That'll take you to Linktree/Connor. That'll give you blog, Facebook, Instagram, Twitter, TikTok, YouTube, podcast, etc., etc., etc. So all the links you could possibly imagine. I like talking tech. That's why I'm thrilled to be. Does everyone feel good about face-to-face? Now, I'm so over Zoom, absolutely so over Zoom. So very happy that you came along. I used to travel for most of my work, and then obviously COVID screwed that. So it's happy to actually see people that I know and love, which is cool. What motivated this talk is the moment 21C came out, WhatsApp fires up, LinkedIn fires up. Everyone's just like, hey Connor, let's talk 21C features, which is a weird thing because, and I understand that people have that thing of, oh, new release, let's all do this. But let's be realistically, very few of you are probably going to be going to 21C, right? But so I've got two important messages for you in this session, right? And the first one is you must use 21C. That's message number one that I want you to take away from this meeting. And the second one is you must not use 21C. They're the two key messages out of this meeting. At which point you're thinking, that guy's just a hypocrite. I'm an Australian, of course we're a hypocrite. But hopefully I can justify both those positions to you. And I'm not saying it's one or the other. I'm saying it's important that you adopt both positions. So I'm not a hypocrite. There's a reason for this. So it's really about choices. And these are some of the choices that we have. For ages, people used to crap on Oracle. They would say, you say there's this new feature coming out, but it's coming out in version 12, which is 5 years away because we're on 11, etc. And people would be grumpy about us. They'd say, look, there's so long between releases. And so we changed that to being more aggressive to actually get releases to people sooner. And then, of course, we had other criticisms and saying we can't keep up. So we have two kinds of customers. Right? And the first customer, I'll use the politically correct term, is the WTH customer, the what the hell customer. And those customers are this, like, my database runs fine. I'm on version 7 or version 11. It runs fine, does what I need to do. Why are you doing all these releases? Leave me the hell alone, right? And that's this. Basically, I just want to make sure my database is secure. Otherwise, don't give me grief. I don't want to upgrade. I'm sick of it. Plenty of customers like that. The other customer is the opposite, the OMG customer, the oh my goodness customer, which is every time there's a new release, they're like, give me that feature, right? Like I don't want to wait 5 years for version 12 to come out. I need that feature today, right? It's going to give me a business critical competitive edge over other people. And it used to be the case that we'd sort of catered to perhaps the first kind of customer and not so much to these customers. But we changed our release model, as you've probably seen a few years back, to actually cater to both. We have much more frequent releases, so we cater to these people, but we don't force people to move. And one message that's important is you can do this at a database level. I have one customer here in Perth, who shall remain nameless, 2 databases. Their data warehouse looks like this. They were on 11.2. They went from 11.2 to 12.1. Why? To get pattern matching, because doing trend analysis is critical in data warehousing. So pattern matching clause came in 12.1. That's why they moved to sole reason for upgrading. 12.102 for in-memory, because data warehouse and in-memory, as we'll see later on, is super. 12.2 for online table move. So you can do compression of data warehouse data without having to take your system online. And they moved to 19 because that's our long-term support release. And they're moving to 21. I can't remember why they're moving to 21. What's the feature thereafter? Oh, SQL macros, which we'll also talk about. So for one database in their organization, they have aggressively upgraded on a feature-based mindset because the data warehouse, right, basically the risk portfolio is not so high for them, don't do so much regression testing. They can just go for it hammer and tongs. Same customer, same data center. Their OLTP database, they've done this. They were happy on 11.204, ran fine, it's brilliant for transactional processing. They moved to 12.2 for the same reason, alter table move online, right? If you're an OLTP system that can never go down, moving objects online is superb. And now they're moving to 19 because 19 is a long-term support release. And I'll clarify what that means in a second. So at a database by database level, you can choose your upgrade strategy. The key thing is we've worked really hard inside Oracle to make that ability available to you. People, hang crap on us about having all these releases, but we've done it on customer demand. We didn't just invent this stuff, right? Some customers said, I want to be able to choose very tight timescales for upgrades. Other people said, look, I just want to do it as little upgrades as possible. So let me tell you why you should not use 21C, firstly. And that's very, very simple. I didn't put the MOS note. There's a MOS note number on this. I'm sure we can find it for you, which talks about our official release timelines. And as you can see, this is the key one, right? If you're on 19C today, you've probably got a decade of being able to stay on that release without needing to upgrade. If you're on 21C today, in 12 months' time, you need to get off it. So if you're happy with upgrading, if you're at the database, which, yep, it's low risk, I'm happy to upgrade, I don't need extensive regression testing, I can just know that the thing's pretty much going to work, 19, 21, 23, etc. is a great path for you. You get the best features, newest features available at an earlier time frame. But if you're in the other camp where every time you do an upgrade, 25 managers say, fine, we need to put together a project team. We need to get a budget. We need to get a schedule. We need to do a regression test. We need to plan this. We need 25 new environments. We have to get our testers in line. We have to get our developers in line. We have to get our users available for testing. And it's a huge effort. And you're going, I just want to go from 19.2 to 19.3. Like, it doesn't matter. It's a 9-month exercise. Then 19C is where you want to be. And for love of money, you should not go to 21C. Because in 12 months' time, you'll be doing the same trip to your manager's office saying, I need that team again because we need to upgrade because we're out of support. So 19C, for those who don't like upgrades because of the various political reasons or whatever, 19C is where you want to be. Because you get there today and you can be there till pretty much the next 10 years. That's a pretty cool place to be. And you still get patches. Like the current version of 19 that's out is 19.16. There's been 16 sets of patches for 19C already. So, and literally there'll be another 25 to come over the next decade. So that's where you want to be. That's why if you're people in the room who don't like upgrading, and I'd say that's probably the majority in Perth, generally people in Perth, we tend to be cautious. 19C is where you want to be. And you really don't want to go to 21C. For that reason, if you're currently on any of these, which I reckon is a whole stack of us, look, particularly if I point at this one, there is a one-step upgrade. You don't have to jump anything. You just download Auto Upgrade. If you haven't heard of Auto Upgrade is fantastic. You know, the days of opening up the upgrade manual, which is like this thick, and doing the 37 preliminary steps, and then upgrading, and then the 512 post-upgrade steps, is pretty much a thing of the past. Download Auto Upgrade, and it's that in a package. So Auto Upgrade, you pretty much run it, and it just runs the upgrade with the preliminary steps and the post-upgrade steps. Auto Upgrade will take you from any of these releases straight to 19C, and one and done, which is cool. To emphasize the fact that 21C is a release for people who are innovators, who are happy to upgrade frequently, we don't even release 21C on some platforms. If you're on an AIX, you're not getting 21C because it's not strategic. You want to be on 19C. Even on our autonomous cloud offering, right, we don't give you 21C as a paid option. If you're using the free cloud database, which we encourage, I'll show you that later on, you get 21C to play with, to explore. But in terms of running a production system on 21C, we don't recommend it on our cloud because 19C is that long-term support release. Most cloud customers are looking for absolute stability. So let's flip the argument over why you must use 21C. Let me give you 4 simple examples as to why, if you're a developer or DBA in the room, you really want to have your head around 21C, even if you never plan to use it in production. First example is, quick, DBAs in the room? Okay, devs in the room? Mix, cool. How do you connect to a database? Everyone knows you go to Oracle Home Network Admin, because that's where tnsnames.aura is. You create a TNS names entry. There's MyDB. I assure you that this is all correct. There's no typos in there. It's a correct link. And then you try connect. And in 21C, this is your first experience. You've just installed it, you create a TNS names entry, and you can't connect. Can't do it. You think, well, what happened? Well, in 21C, that's not where tnsnames.aura lives anymore. All those years we've had it, don't do that anymore. If you go to this link, it points to the fact that Oracle, way back in 18C, introduced a thing called the read-only Oracle Home. We rejigged the software such that the Oracle Home binaries can be read-only, which is great if you're doing things like Docker images. You don't have to actually touch it. And the things that change, tnsnames.aura, SQLnet.aura, password file, SP file, are elsewhere. And in 21C, that's the default. So it's not a feature we invented in 21C, it's back in 18C, but it's the default in 21C. And so you had, even out in Stack Overflow, people going, oh, I can't connect to 21C, it's all broken, I don't use it. They didn't read the docs. But we've changed the way things work in 21C. So if you're never planning on going to 21C, eventually you'll go from 19 to 23, which is the next big long-term support release. And rather than get that surprise when you're trying to go from 19 to 23, you go, because 23 will be the same as 21, you may as well start learning these little idiosyncrasies now with 21, such that your move from 19 to 23 is painless. That's why you need to use 21C. Example 2, if you're a DBA, we all know that we eventually, over time, we went from case-insensitive to case-sensitive passwords. And a lot of DBAs went, oh, that's okay, I'll just use this, the ignore case parameter, because I don't have to change my work processes. And therefore, I try, that's my secret password, but I don't have to worry about the case. In 21C, when you try don't use that, it won't work. We ignore the ignore case parameter in 21C. We said, tough, time's up. We told you back in 12.1 that you had to go case sensitive. Now we're enforcing it. So that's another little shock you'll get. Plenty of seats, please, feel free. I actually prefer people standing because it makes the room look full. Example for the developers. You may have used DBMS Obfuscation Toolkit to do some of the cryptographic functions inside Oracle, encryption, decryption, etc., etc. That's how it looks in 19C. Encrypt this password, comes out of some gobbledygook. That's how it looks in 21C. That routine's gone, desupported. Use DBMS Crypto now, not DBMS Obfuscation Toolkit. These are all little surprises that it's good to encounter now on 21C on your little play database and not when you're trying to go to 23C in production. Fourth example, in 21C onwards, you cannot have a non-pluggable database. It's all pluggable. Anyone here still running on non-pluggable database stuff? Yeah, I knew it. I knew it. Yeah, so in 21C, it's not an option, right? You must use the pluggable database architecture. In 19, you can use either, but in 21C, that's it. And why that's important? Because when you move to 23C, it's the same. So that's why it's super important to have 21C to play with now, even if you never want to use it in production. We'll talk more about pluggables later. Now, the best way to learn 21C, we give it to you for free, right? It blows me away that people don't use this more often than they do, right? I want to stress, this is a plus sign. People get confused. They say, you give us this free offering, but you only get 30 days. That's wrong. We give you a whole stack of services which are free forever, right? And I have an Oracle Cloud database running here because I basically, I log what was meant to be my exercise program in an Apex database. It's a relatively empty table at the moment, but the plan was to log exercise in there. But I thought, why would I stand up my own Apex instance when I get a Exadata-based free database forever? Like, it's free. Plus, you get 30 days to play with all the other stuff that's not free. So that expires, but this stuff you get forever. If you Google for some of the things, like I know people that literally ditched, they have blogs. They ditched WordPress because you pay $100 a year. They run their blogs. They don't even use the Oracle database. They just say, cool, free VM. Fantastic. I'll run my WordPress blog off that. It's free forever. That's super cool. For those in the room, like, cloud mistrust, don't like these cloud people, you can also get Express Edition 21C to run on your own machine, okay, Windows and Linux. So that's the best way. So the rest of this session, the rest of the next 60 minutes is a bit of a sampler, right? Like a degustation menu. I don't want to dive too deep into every feature because we won't cover enough. I just want to give you a little teaser on each one to hopefully inspire you to go and play with it yourself. Now that you can get 21C on cloud or on premise, you can just go away and play with this stuff yourself and become experts in it. As I said, we got 21, in fact, 22 features we could cover. I don't think we'll get that far, but we'll do our best. Other than that, let's just jump straight into it. Quick sip of the coffee, keep the energy levels up. Number one, McDonald's law of high availability is uptime doesn't matter. Like people are like, grab the popcorn. This is going to be weird because everyone's like, oh, we have an outage, right? Uptime matters a bit, right, in my view, but it doesn't matter as much as security. And let me try to prove that to you. It's and don't get me wrong, Oracle's as guilty as any vendor in the marketplace. We sell you HA solutions. It's so important that you never go down. If a customer can't touch your website in 3 seconds, they'll move onwards. We've all heard those cliches, right? But like, look at some of the big outages. Delta Airlines, the Azure, Cloud, Amazon, etc. There's heaps, right? And I'm not claiming that Oracle's immune to this. But if you go to your bank and can't use the ATM, you don't go, oh, screw you, Commonwealth Bank. I'm never banking here again. I'm changing to NAB. No, you go, oh, damn it, I'll come back tomorrow. You will forgive an outage unless it's not an incredible impingement upon you. What you won't ever be forgive for is if you get hacked, right? If you're a customer of a bank and your bank got hacked, like, you're out of there. Well, actually, I would be, right? Security trumps uptime. Sounds weird, but it does. And hacks is just coming out of woodwork nowadays. Like, every day there's a new breach, and like literally you get put out of business if you get hacked. I want to talk about blockchain, which is the 21C feature. Most people, when they hear blockchain, think crypto. I used to think crypto until I bought some crypto, and that didn't work out so well. So the key thing with blockchain is really it's an indisputable record of events. And we have this thing in Oracle called a blockchain table in 21C. And the syntax is create blockchain table. Now, what does it do? Really, a blockchain, for those who are unfamiliar, is simply we link our rows with a hash function. So this is blockchain 101, very, very briefly. I'm going to have a row on my table that starts with a balance of 0 and I get a salary of 200. I calculate a hash on those values and I store it in the block. Then what happens is my next transaction says, well, I have my balance of 0 for 200. Now it's gone to 200 and I spent $50 on food, right? And so I hash that and then take the previous hash of the block and this hash, create a new hash, and so on for each transaction. So that's why they call it a blockchain. Every block is linked by a cryptographic hash. The reason that's secure is if someone came along and tried to diddle this number, try to hack you in some way, then immediately it invalidates all of these hashes. They would all have to be recalculated, and that's time expensive. That's how blockchains work. It's too expensive to hack the data. And that's what blockchain is. So this is how we do it inside the database. Don't get me wrong, we're not saying we have a blockchain ledger out there. We're not doing crypto. This is simply a way of having an indisputable records of events inside the database. So create blockchain table, and you can nominate. The table can't be dropped. You can even nominate after the records are inserted. I'm not allowed to delete them until 8 days. If I say locked, I can't change that 8 days. That's 8 days is fixed. I can't do an alter table afterwards. If it's not locked, I can change that, but it has to go upwards. So once I say you can't delete a record until after 8 days, then the only thing I can ever do is increase that to 10 or 12 or 14, but I can't. I have to wait those 8 days. That's a blockchain table. How do we implement it? Here's my table, and here's all the hidden columns we add at the end of it. So every time you commit a row, we go and do some calculation work to populate all these values to create this link of hashing information across the records. That's blockchain tables. Number 2, people in the room going, I knew we'd start with blockchain. You know, it's the trendy term, yada, 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 and we're never going to use it. So why do we start? And it's true. You know, like when 21C came out, every blog post that we came out of Oracle was a blockchain blog post. Oh, look at this cool technology we got. But the reality is a lot of you probably won't use it because it's a fairly niche feature. You know, this is my favorite blockchain slide, flowchart. Should I use blockchain? Am I building crypto? Yes, then don't, please. There's enough cryptos out there. And if you're not, then you probably don't need a blockchain. What we do want, though, is something a little more nuanced, which is this is one of the biggest challenges that face companies that have secure data. That I've locked down all the security, but there's always that one person that can change the data. The admin, the DBA can change data. How do we protect against that? In the past, we recommended Database Vault for that. Database Vault solves this problem. Database Vault solves 150 other problems as well. It's a massive product, super cool. So many things you can do with Database Vault of this, which is one. The problem is people go, that's a big solution to this one little issue I have. Right? And don't get me wrong, I love Database Vault. There's so many cool things in terms of role access and whatever, but it's a big solution to this one little thing I'd like to tick off. And that's where a variant of a blockchain table is what we call an immutable table, which looks like this. Create a mutable table. I've called it no messing around because you're not allowed to mess around with it. And the syntax looks very similar to a blockchain table. So we're instigating the same rules as a blockchain without the blockchain concept. We're not doing crypto and hashing and stuff. It's just introducing rules around a table. So in this case, you can't drop it until the table has had no DML for a day. In this case, you can't delete a row until it's 16 days after it's inserted. So because it's an indisputable record of events, the only thing you can do is insert. You can only delete after 16 days in this example. You can't update. For example, here's my no messing around table. I try to update it. It says this operation is not allowed on a blockchain or immutable table. Now, that looks unimpressive until I show you the last line, which is I tried to do that as sys, and sys can't do it either. Right? You immediately lock. The only thing you can do is insert. If you need to change the state of a row, you insert a new row with the new status. The old row stays around. It's immutable, hence the definition. You cannot drop or truncate one of these tables. And when I say cannot drop, until after that time limit has expired. Right? Now, if anyone with a mobile phone, screenshot that slide. Right? Because we're not mucking around here. This isn't like, well, people say, oh, we want a table that, is immutable. We said, we got one. Right? And then people say, well, I didn't want it to be that immutable. Well, that's what immutable is a Boolean. It's true or false. E.g., if I try drop the entire table, I can't. If I try drop the table space that table's in, you can't. Once you've created an immutable table and you want to get rid of it before the expiry date, the only way you can do it is to drop the entire database. That's it.
You can't drop the schema.
Nope. Must drop the entire database. Be careful what you wish for, right? It's there, right? Now, important thing, flick back a bit. Oh, I shouldn't go back. Careful what you choose here. If you type in no drop until 1,000 days, You've got that table for 1,000 days. There is no way getting around it. It's there for good. Now, for that reason, there is a parameter in the database which let you set an upper limit for what people can use. So if you set max drop to, say, 0, no one can set anything more than I can drop the table immediately. So in your environments, I would suggest you put that if people are just playing around with this. But if you don't, and someone puts no drop until forever, which you can, that's not parameter as well, that table's with you forever. Like it's never going away. So be aware. Yeah. No. It's there and it's there forever. Joy.
Do you have to drop the whole plug?
Yeah.
Like everything, all the other ones.
Entire pluggable database. If you're on non-pluggable, because blockchain has been backported to 19C, if you're on a non-pluggable database and you create a blockchain table on there, the only way of getting rid of it is to drop your entire database.
All right. But if you've got a database plugged in, it's only the one that you've plugged in.
Yes, only the plugger. Yeah, just the pluggable, not the entire container.
Flashback to another one?
Nope. Be careful.
You might think of a way around it.
That's right, yeah. Yeah. Now, before you all crap on me, you asked for this. We didn't invent this. Like people said, we want something that you can't drop. We said, we got one. And I didn't really mean that, but yeah, there you go. Number 3. This is what I call the going out to lunch problem. And historically, what would happen is some would, in the good old client server days, some would open a transaction, walk away from their desk, and the rest of the world collapses because they've got a locked row that no one can touch. Now, that has sort of dissipated a bit over the time as we go to more multi-tier architectures, but it still exists. One of the nice things, once again, 21C has been backported to 19C because it's so popular, is this one. Set max idle blocker time equals 1. Sadly, it's in minutes, not seconds, so the lowest is a minute. If someone has got an open lock, but they are idle, their session is no longer active, and someone else is trying to get that lock, after 1 minute, that idle session will be turfed. So you don't have to worry about it. You don't have to have those pager alerts coming as a DBA. So simple example, session 1 does a delete, walks away from their desk. Session 2 tries to get that row and they wait. And then approximately after a minute, in this case, it was 47 seconds because it's just on a schedule. It said, yep, session 1 got turfed. So this person will now get the lock. The elapsed time means they finally got the lock. So you don't have to be one of those DBAs now constantly monitoring for blocked locks. If you set that after a minute, people trying to get a lock will get the lock because the other session will be turfed because they were idle. When I present this, people say, that's okay. We use Apex or we use C# or Java. We use a connection pooling architecture nowadays. So we don't have the concept of people walking away from their desk, leaving rows unlocked. It's true. It's not people that walk away from the desk. What happens now is connection pools walk away from the desk in the sense that when you have a failed connection pool session, like it crashes, the Java session crashes, etc., it can leave sessions open as well. So you end up with this thing where this person is inactive, but they have a lock, they're logged on as Apex, session 39, and then other Apex users come in and they get stuck on session 39, and then others get stuck on 36, etc. So you get this cascading effect even in connection pools, because connection pools generally have a long time before they time themselves out and release their locks. And the funny thing is when you look at this kind of stuff, if you look at the client identifier, you notice it's always the same person. Because what happens is if you're an Apex or any kind of web platform, you press button and you get hourglass. What do? Bring up another tab, try again. Bang up another tab, try again to make sure it's not just a latency issue, whatever. So often these problems are of people's own making. But I would set that max idle block time on every database I have. Just solves a lot of hassles. Number 4, PL SQL iteration. This all started with teasing, right? People were teasing us. In any language, you can choose the increment of a loop. It's normally the third parameter. JavaScript lets me choose a size. I want to jump up by 1 or 2 or 3. C# lets me choose a size. Java lets me choose a size because PL SQL you can't. Everyone's teasing us. People said even BASIC lets me choose a size. You fire up a Commodore 64 and you can do step by 2. You can't do it in PL SQL. Now, my advice is, don't poke the bear. Right? Because this is what happened is that got back to the PL SQL dev team. And they're like, we're going to show them. And so we might have got a bit carried away. So let's look at how things used to be and how you can do them in 21C onwards. So if you wanted to go from 1 to 10, 100 to 110, 200 to 210 in the past, you wrote 3 separate loops. In 21C, you just put it all on one line. 1 to 10, 100, 110, etc. So simple change. If you wanted to go by 3, you would have to do something like a modulo function or something. So I want to go from 1 to 20, but only for every third one, so 1, 4, 7, 9. And finally, we just go 1 to 20 by 3. So that's now in there. We didn't use step. We didn't go back to basic, but yeah, by 3. I can even go by 0.5. Now, that looks a bit weird because I said go by 0.5, but I didn't. Anyone like to hazard a guess as to why? Because the data type of a loop variable is an integer. So it got rounded. But in 21C, you can choose the data type of the loop variable. So I want to go number 31, and I go from 0.5. And the moment you can choose the data type of the variable, that opens up a whole lot of other opportunities as well. For example, but we'll get to that. If I wanted to loop through, say, the powers of 2 in 19C, I would have to have some sort of calculation. So, you know, bit and power, etc., to see what the bit performance of that integer is. I'd have to do it in first principles. In 21C, I can go for power in 1, repeat power equals power times 2 while it's less than 1024. So now I've got repeat and while loops inside a for loop, just along the one line declaration. I told you got carried away. I can have a when clause on a for loop now. So I want to go from 1 to 100 when is prime, this is a pure SQL function I wrote, that's not native, but if it's a prime number, but it's not 19 or 32nd, then I get all the prime numbers, but all now in a loop definition. I have when, etc. I can do something like this. I can go from 1 to 10, then add I plus 1 while I is less than 5, then from 6 to 15 by trunk I. I don't know why I want to do this, but I could. And you get this. You can see it bounces around. It starts. You can do lots of different things, just over and over. And we haven't even got started yet, right? I said, don't poke the bear. So if I open up a ref cursor back in the day, this is how I'd have to loop through it in 19C and below. I open the ref cursor, declare some record types, fetch it, bulk collect, loop around. We're all familiar with that if we're PL SQL coders. In 21C, I just go for R. It's a number data type in the values of this ref cursor, because this ref cursor was just selecting a numeric data type. So I just want R number in the values of the ref cursor, and out come the employee numbers. Nice and easy. Of course, what if the cursor has 2 variables? Well, I declare a record type, R1 and R2, number varchar. For R, as I said, I can now nominate the record type, the data type of the loop variable. So for R of type rec, in the values of the ref cursor, and out they come. It could be dynamic SQL. You could have a string called in the SQL for R rec type in, execute immediate inside the for loop when the employee less than 700 and loop through that. You shouldn't have teased us. We have mutability controls. I can say I is now mutable, which means you can change the loop variable inside the loop, something you could never do. It used to be read-only in 19C and below. And the default is immutable, so we have backward compatibility. So if you don't specify it, it's immutable. As a result, for example, I could have a procedure which takes in, say, a row type variable and makes changes to that variable, and then I could say, I is select star from M, which means its data type will match the row type variable, and I could actually pass that into procedures and make changes to the variable as it goes in and out of the procedure. So I don't think there's anything left in PL SQL loops that you could think of that isn't covered in there, which is cool. Let's continue on. PL SQL qualified expressions, which is like arrays. If I ever wanted to assign values to an array in PL SQL, I want to store values in S1 through to S9, I have to do it in a loop. S1 to 9, Si equals I times 10. That's how you do multiple assignments into arrays. In 21C, also in 19C, we introduce this. You can nominate the pairs. Index 1 gets a value of 10, index 2 gets a value of 20, index 3 gets a value of 30, and so on, which is fine, but it's a bit unwieldy. You have to do a lot of typing in there. In 21C, in the same way we could assign something to a nested table, we can now do it to an associative array. We just nominate the values. There's a constructor now for PL SQL arrays. Now, if you're dealing with arrays, as we saw in the very first demo, you're typically looping through them. So it's really just for loops in disguise. So all that stuff you just saw, how we've extended for loops, now gets put into array definitions as well. So if I have a variable here, S1, which has indexes 1 through 10, is it 1 through 10? Yeah. and I want to copy every second entry to a new array, this is how I'd have to do it in Oracle 19. I assign the values 1 to 10, and then this one, if it's every second one, then copy it to S2. In 21C, I can put a for loop inside an array definition. I can say S1 is num list 1 through 10, S2 is num list for I in 2 to 10 by 2, copy the second element. And that'll get me the same result. So now we have for loops inside array constructors. And because they're for loops, we got lots of goodies that come along it. That array I just built, S2, which has index entries 2, 4, 6, 8, and 10, I can't just loop through it because it's a sparsely created array. This is how I have to loop through it in 19C. Find the first one. If it's not null, then print it out, and then find the next one and jump through the indexes as we go. In 21C, for IDX in the indices of S2, then IDX becomes 2, 4, 6, 8, 10. Just loop through it straight away. If I want the values, I just IDX in the values of S2. So rather than getting the index numbers, I get the actual array values themselves. So I get the 20, 40, 60, 80. I think that's 100. Oh no, I actually put 1,000. Oh, there you go. So once again, for loops now, easy to traverse arrays in for loops. If I want both the index and the values, so I want 2, 4, 6, 8, 10, the actual index numbers for the array, and the values for those elements, I can do for X and Y in the pairs of the array. And I get X gets the 2, 4, 6, 8, 10, the index numbers, and Y gets the index values. A lot of flexibility in there. I can say all the stuff that came out in for loops, I can now stick into arrays. So in this case, I'm saying I want to create an array. The indexes are 1 through 5, but the values get I times 10. So I get 1, 2, 3, 4, 5, 10, 20, 30, 40, 50. I can say for I in 1 to 5, index I plus 8. So start at 9 and store the value I times 10. So I don't have to start at 1. If I do for I from 6 to 12, I can say I want to sequence my array, which means sequence means start from 1. So even though my index goes from 6 to 12, because I want to do 60, 70, 80, the actual array starts at 1 because I use the word sequence. So it's a sequenced array. If I do this, what have I got here? Why did I put this one in here? Ah, yes. This is a table of number. So it's no longer an associative array, it's a nested table. So slightly different thing in PL SQL for those familiar with it. I can do the same thing here. I can put values in the same way. So it still works with nested tables. I'll put this in here because if you start at index 1 plus I plus 3, nested tables always start at 1. You can't avoid it. They must start at 1. So in this case, if you said I want to start at index 4, we actually automatically populate 1 through 3 with null. So it's a little gotcha there if you're using nested tables. Because the for loops have been extended, so have arrays. I want to populate an array with the output of a SQL statement as I construct the array. No longer fetch, bulk, collect, all that kind of stuff. So in this case, I'm simply saying select EMA and the sequence, so start from 1 through 6 and put the employee name in there. I can do select employee number ename and use P and Q, which actually says now I want to populate an array using a for loop, which uses an SQL statement, and the index is actually an element that comes out of the SQL statement. So I can build what we would normally call a hash array with a single line now. And just to round that off, oh no, I'm going to go further. Yeah, this one. I could have a dynamic SQL. I could have construct an array using a for loop by running a piece of dynamic SQL, looping through the dynamic SQL results and populating an array. I told you not to poke the bear. It's insane what you can do now. I mean, the time it would take to refactor code, to take advantage of this is large. So we'd encourage this for new projects because the other code works just fine, but this is just so much more compact and neat and self-documenting. And yeah, and the next person that says, you guys need a step command, well, there you go. We got everything you could think of. How are we going for time? Oh, not that great. Okay, in-memory, who uses in-memory here? Yeah. Now, can anyone think of one reason, just one, why a lot of people don't use in-memory? Yeah, I've got an idea. Might be that, right? It's expensive. And don't get me wrong, someone has to pay my wage, and I'm happy we charge a lot for it. No, I digress. The reality is, Oracle's not stupid. I've never done an in-memory demo for any customer where they haven't gone, wow, Like, it is a super cool feature. It's insanely cool. And unfortunately, the big wigs at Oracle go, you know, we know how cool that is, so we're going to charge a ton for it. And it's expensive. That's an unfortunate fact of life. But what if I said to you, you could have a little bit of in-memory for free, right? No charge. As of 21C, and this thing was so popular, this got backported to, like, I think even the base release of 19. In-memory force, you set it to base level. Base level gets you 16 gigabytes of in-memory for free on any version of the database, right, that supports in-memory. So no fees, no whatever. Now, people go 16 gig. Yeah, that's a laptop, that's useless. Yeah, how am I getting some benefit out of that? Let me give you an example. Let's create a little star schema here. Very, very simple. Customer products, 1,200 products. Customers, 10,000 customers. They're their dimensions. Sitting on top of a fact table, customer sales, which is 250 million rows. Now, that's non-trivial. It's not massive, but it's non-trivial, right? How big is that table? 12 gigs, right? You can fit a lot of data into 12 gigs. Now, that's not 12 gigs of in-memory that you'll use, because when you put stuff into the in-memory store, it's compressed. So let's take a typical warehouse query. I'm joining those three tables. Customer sales, that's my fact table to the customers. I got some where clauses here. I got some group bys, etc. I'm then joining the result to customer products. It's a typical sort of complicated aggregation analytic style query. Without in-memory, it's 75 seconds on this poor little Dell laptop. I take those three tables, I put them into in-memory. Now it's 2 seconds. That's a 35-fold benefit, right? And it's free. There's no charge for this. Like, you would be insane not to go back to your database today and go, I'm on 19C, let's give myself 16 gig of in-memory for nothing, right? And people say, oh yeah, it's only 16 gig. The benefits here, especially for systems where you have partition tables, because it's true, you cannot fit your 5 terabyte partition table into 16 gigs of in-memory, granted. But you could probably fit, for example, your most recent partition, and therefore give analytic style queries on that, right? And that's actually a popular thing. People, it sounds weird, but we have people that actually take their indexes off their current partition, because that means transactions go in much, much faster, and they solve all their queries using in-memory just on that current partition. Then they use partial indexing to put indexes on all the older partitions because they can't fit it into in-memory. That way they get a lot of the benefits of in-memory, and they did not pay a cent. I hate saying that, because I'd much rather you pay some money for me so I stay in a job, but 16 gig for nothing. Super cool. If you're on rack, you get 16 gigs for each instance, so you can get that multiplier effect as well. Number 7, safer data pump. This is one for the DBAs in the room. If I do a data pump of the Scott schema, right, easy peasy, it creates a data pump file. And people think just because it's a file outside the database that it's in some ways special, but it's not. I can VI that file, open up a hex editor, and I'll just go change Martin to Connor. Just overtype the characters, right? And then import that data, and look, Martin is now Connor, and no one knew. Yeah, because the data pump file is unprotected. It's outside the database. And especially nowadays in cloud environments where data pump files end up being an object store, if you haven't properly credentialed your object store, then anyone can get to it. Right? So once data's outside the database, it's free for all. So in 21, we now have a checksum function on data pump, which obviously I'd recommend for everyone. Put a checksum on your data pump file to make sure it's not going to be tinkered with. Now, one thing that's important is this, for backward compatibility reasons, is important. If you put a checksum on the data pump export, that does not mean that we'll automatically check for it on import, right? You have to be verified checksum equals yes, because if you don't, we'll happily import it even though you put a checksum in there. So it's a two-phase operation. Add the checksum on export, nominate verification on import, and then we'll make sure that, yep, someone's been behind the scenes and diddled your data. Number 8, gradual password rollover. Let's do a very simple demo. It's done with a profile. I've got a profile called Let's Be Gentle. Let's be gentle to our users. They get 4 days where they can use an old and a new password. So in this case, I'll create a user called demo. Their password is my current password. And they're in the Let's Be Gentle profile. Give them session. I can connect as my current password. That's obviously simple. Auditors come along. They say, every password must be changed every 30 days. So we change the demo to pesky auditor's new password. But they can obviously connect as the new password because we just changed it. But for 4 days, they can connect as the old password as well. Now, people say, who cares? They're users. Just tell them to use a new password. If you get old password, just use a new password. It's nothing to do with users, right? The motivation for this feature is actually not users, it's app servers. Because on app servers, we typically use wallets. So we don't have to specify passwords in config files. Or if you do, either way, you still got passwords floating around somewhere. So I have all these things hit into our database, and the app wallet contains Scott/Tiger. When I come along and change Scott to Leopard, in days gone by, that immediately breaks all the apps. They can no longer connect. So you generally had to have an outage of some sort to change the password for app servers. And that's a problem because people don't like outages. So what we do is we do effectively rolling passwords. So what you do is you would change the password, give it a 4-day rollover. You've got 4 days to go update these wallets on your 10,000 app servers. So it's so you don't have to ever take app servers down. That's the motivation for this feature. The good thing is we detect it. So if you look at your unified audit trail, if they are connecting, it'll say they use the new password, they use the old password. Even though it says 12C, that's for all versions. It's the 12C password type they're using, not the 12C database. So you'll see that they use a new password, they use the old password, so you can actually monitor this stuff. Similarly, if someone's in that 4-day period, you can see that they're in rollover by looking at DBA users. So it's not like this mysterious magic going on behind the scenes. You can actually see what's going on. Number 9, we get a few more in before we jump ahead. SQL set extensions. You can sort of see I'm trying to toggle here between DBA and developer features, so at least half the people go home happy half the time. Let's create a couple of tables. One's the employee table. It's the 14 rows from scott.emp. Here's emp department 10, which is just the 3 rows, I think, that have department 10 in them. So we have a table which is a subset of the other. If we wanted to see which rows are in one table but not the other, you're probably familiar with the minus thing, which has been around since Oracle 7, I think. And so this is the 11 rows in Scott, 11 rows in emp that are not in emp department 10. Now, the star is actually what defines distinctness. So because I selected all the columns, the database looks for any differences in any of the columns and decides, okay, any column that's different means bring out that difference, which is why I got all 11 rows. If I just did select department number, not select star, I only get 2 rows back because effectively it's like a distinct, it's like a union command. There's, yes, there's 11 rows, but there's only 2 different departments when I do department minus department here. So we always get that sort of collapsing of rows and in the distinct values when you do a minus command. In 21C, we've introduced the except, which is pretty much the exact same as minus, except this is the ANSI standard syntax. Minus is not ANSI standard, except is. But while we're doing this process, we added some extensions to all our operators. So in the same way that you have union and union all, we now have except and except all. So even though I'm just doing department number, I don't get the distinct list, I get the full list of 11 rows, even though we have some repeated entries there. Yeah, I said think union all. So union always does distinct, union all does not, same with except and except all. And we've expanded all the existing clauses. So intersect, which we've always had, now has intersect all. Minus now has union distinct now. Union distinct is exactly the same as union, but this is ANSI standard. It's now documentation completeness, blah, blah, blah. Really, so it's really just what I call syntax sugar, right? It's making sure that the Oracle database now observes even more of the ANSI standard. And this is effectively union distinct is just union, etc., etc. But except is the same as minus, except all is minus all, except distinct is minus, etc. So all the old ones still work, but now we have these new ones. So if you're porting from, say, Postgres SQL Server to Oracle, you don't have to go revisit your code. Number 10, the checksum function, DBA/developer. You can now do a checksum on a grouping. So it's an aggregation function like sum, min, max, etc. So if I want to take all the employee names for each department number and do a checksum on them, I get this numeric result. So the 5 employees that belong to department 20, take the employee names and do a checksum across them. Useful if I'm doing data comparisons. I've done a data load from one place to another. I want to do a quick check to make sure that things are probably identical. checksum function's good for that. Unfortunately, it can't take multiple columns. So if you want to checksum several columns, you need to have checksum, 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 which I think sucks. I don't like the way we implemented that, but we are where we are. If you needed to work around that, if you want to do a checksum of all the data, which is, I would imagine, our most common requirement, what you could do is, for example, do the JSON object facility, because JSON will take as many columns as you want, or even star, and create you a JSON fragment. And now it's just one thing. It's a piece of JSON. And I could therefore put a checksum around the JSON. So you can do it that way if you want to. I'd prefer, I would have loved checksum star. That would have been great, but we don't have it. Number 11, analytics. When I say analytics, anything that any SQL you had that uses the over function, like row number over, min max over, etc., dense rank, etc. What we notice is that generally when people are using one analytic function, they use the same construct many, many, many times. Because people say, I want the max, I want the min, I want the average, I want the max, the min, the average, and this thing gets repeated over and over and over, and you're into copy-paste hell. So what we introduced was a shorthand. We said you can define a thing called a window, I'll call it W department, which is partitioned by department number. And now you can reference that in any part of the code. So it's just a nice shorthand for you. And the good thing is, this is effectively, call it a substitution text. So it's not bound, like you can actually extend it. So for example, I could say, my window is partitioned by department number. This one I want, use that part and then add order by salary as well. So I can extend it in any way I want. It's really just a syntax shorthand for grabbing that and stuffing it into there. Similarly, I could do like, order by sale plus a window clause, etc. So it's just a really shorthand to make, it just stops someone in here doing a simple typo and totally ruining your day. We have some more analytics as well coming in 21C. Let's look at, for example, the employee table, and using an analytic here, let's look at how far the salary deviates from the average salary. Now, this is really just to paint the picture of how this data is. You can see most of them are actually under the average salary in the table. So most of the data is actually below the average. We now have, mainly under the average. We now have a skew function in Oracle in 21C, which shows you the skew of a particular piece of data. Now, what does this 1.04 mean? Well, if a skew is 0, it means most of the data is around the average. If a skew is positive, negative, positive, it means most of the data is under the average. You would have to skew the data by 1.04 to move this back to the average. Does that make sense? And then if the skew is negative, we have most of the data above the average. So you now have a skew function to actually give this information. Number 12, yeah, we can get a few more in. How are we going? Everyone's brains full already? Nope. Cool, cruising along. JSON. I'm a CSV baby. Yeah, when I was born, CSV was the only data interchange format we would ever need. And then it's like, CSV is so old school. It's XML. XML is the only data interchange format we will ever need. And they're like, XML, why are you using XML? Now it's JSON. And there's a lot going for XML, unfortunately. But anyway, JSON's the thing nowadays. Everyone's going to have JSON. And we've always had the ability, as far back as 12, I think, simply to slam JSON into a clob in the Oracle database. You have a check constraint, check is JSON, which means it's valid. But that was about it. It's still just a big clobber data you have to do management on. In 21C, we now have a native data type called JSON, which actually stores the data in a binary format. But even though it's a binary format, you can still just insert plain old text in there. No conversions required. I've got some simple JSON. You can see I live in Perth. I've spelt my name wrong, but we'll correct that shortly. And if you describe this table, interesting, if you're using an old client, it won't know what the JSON data type is. It'll say undefined. But if you're on 21C client, it'll say it's JSON. But once you do that, it opens up a whole level of flexibility that you haven't had in the past. E.g., the normal JSON value functions work as before. So they're already in 19C, I think even in 18 and maybe even 12. So they work unchanged, even though it's a brand new data type. Similarly, the dot notation works as well. But we've extended the dot notation. You can now nominate a data type as well. So I want to get this information back from the JSON fragment, but by the way, it's a string. You can say, or it's a date, or it's a number, etc. I can choose to take my JSON data type and pretty it up so it comes back in a nice, pretty format if I want to, using JSON serialize. PL/SQL has been extended to easily handle these JSON data types as well. So I'm going to pass that JSON I had Connor living in Perth into this procedure, but I'm going to take it. I'm going to say, does it have an element called status? If it does, I'm going to change status to platinum with pink sparkles. But if it doesn't, I'm going to add one called silver. So in this case, I JSON serialize, call this procedure, pass in my data, and I didn't have one called status before, so I've added one to my JSON called status silver. So now I can easily plug and play little elements into my JSON fragment just using PL/SQL, using nice native object types. And I can do it just straight out of SQL as well. And it becomes much more easy. It's not like handling clobs anymore. It's like, take that JSON you just saw, which was Connor lives in Perth. Add a new element called last updated. Add a new zip code, American. Add a postcode 6001, correct my name to Connor, change the name element to become first name, and append an array of friends, in this case called Tom. If the array is already there, just add Tom to it. If not, create a brand new array. Just simple DML, and I get this result in JSON. I added zip code of thing, I changed my name to correct it, I changed first name to first name, and I add an array of friends. So really easy to do JSON manipulation now, as opposed to playing with clobs. One thing we've added to JSON as well is JSON natively has arrays inside it. So multiple pieces of information in a single row. Well, how do you index that? How do you index something which has multiple pieces of information? In the past, we'd make you use a text index for it. Now you can have a multi-value index on JSON elements. So even though this one row has both London and Reading and two different zip codes, I'm creating an index called the multi-value index on the zip code. So if I search for 1234, I get the row back I wanted, even though there were multiple zip codes in there, and I use that index to do so. So now it's an index can have multiple values for a single row, something you could never do in the past. A couple other things. We have a thing called JSON scaler, which will take an input and return you the correct JSON phrasing for that input. Now, this looks like the least overwhelming or the most underwhelming function you've ever seen. He's like, I took a string and I put double quotes around it. Woohoo, very impressive. Thanks, Oracle. The real value here comes into when you're not using strings. For example, if I want to put the sysdate into a JSON thing, well, I wouldn't do that because I get the word sysdate. That's obviously not what I wanted. Well, what if I just concatenate sysdate? Well, I get that. Looks okay, but it's invalid JSON because you're not allowed to put dates in that format in JSON. They have to subscribe to ISO 789C1-7 or whatever the hell it is. So if you put JSON scalar sysdate, it'll guarantee you get the correct formatted date in there. Same with numbers, currency, et cetera, et cetera. So that's what JSON scalar is for. How long is this one? Yeah, we can squeeze this one in, I think, and then we'll have to move on. Number 13, better active data guard. Nice, simple one. In 12C, right, who's your primary system? Here's your active standby, right? If you failed over, you had to populate your buffer cache again, populate result cache again. It's like a brand new started system, right? So all that goodness in memory that's making queries run fast, you go through the whole exercise again. In 19C, we keep the buffer cache populated. So we have, less unhappy users. So now when you fail over, anything that was in memory here is already in memory here, and the system pretty much just continues on. And in 21C, anything you had in a result cache is also kept populated. So effectively, when you fail over, generally people won't notice any blip in performance. There's a connection blip, so people need to reconnect, but literally service just resumes as per normal. This is fun. And better active data guard failover. Yes, I can get this one done in time. Who has data guard here, active or not? Yeah, cool. I'd love to give you a 15-minute discussion as to why every single person should have data guard in every single database, because it's ultimately free. But come see me afterwards if you don't believe me why it's free. I'll explain that later. But for this one, failover. This is how most data guard failover is. You're going, here's my primary. Here's the every 6-month test we have to do, or we have a DR situation, and cross our fingers, cross our legs, cross our toes, and go, oh God, I hope it works. Right? That's not a great place to be as a DBA. Nice thing in 21C, validate, fast start failover. And it's going to go through and say, okay, are all your archive logs up to shipped? The shipping's going okay? Is everything populated? Is everything working okay? It's give you that insurance policy that when you fail over, it's going to work, as opposed to that classic thing of it just says, I'm sorry, I didn't fail over. And you go, well, I'm screwed. So that's cool. Okay, it's 9:27. Oh, a whole lot of other broker improvements as well. Yep. It's 9:27. So at this point, I'm going to look down the barrel. I have to say goodbye to our online attendees. Thank you very much. If you want me to come do this in person, get in touch with the user group or get in touch with your your Melbourne or Sydney or Queensland Oracle office. And yeah, I'd love to come travel over there. But for now, bye for now. I'm going to shut the browser down and hopefully we'll see you at the next talk.